Problem along with these four options is very beautiful problem for real analysis. Let an and bn be a sequence of real numbers defined as a1 equal to 1 and for n greater than equal to 1. An plus 1 in terms of an is an plus minus 1 raised to the power n, 2 raised to the power minus n, and bn is another sequence defined in terms of an in numerator 2 times an plus 1 minus an divided by an. Then an converges to 0. Options are, and bn is a Cauchy sequence. An converges to a non-zero number and bn is a Cauchy sequence. An converges to 0 and bn is not a convergent sequence. And fourth one is an converges to a non-zero number and bn is not a convergent sequence. First, understand the hypothesis of this problem. What is the problem and its options. An and bn be two real sequences, and a1, it means first term of sequence a1 is 1, and other terms of an will be an plus 1 can be obtained by minus an plus minus 1 raised to the power n, 2 raised to the power minus n. These are additive inverse, but n coming from set of natural number, and natural number is not a group, so inverse is not possible here. But to understand this problem, n and minus n are additive inverse if I can take these are from the set of integer. But in a intuitive way of or in terms of sequence, these are coming from set of numbers, but you can understand better or more precisely. If n is here, then minus n here, it means negative appear in 2 raised to the power in terms of raised to the power. Now bn is sequence and its nth term defined by 2 an plus 1, 2 times an plus 1 minus an divided by an. bn is coming or obtained from by the sequence an, but we cannot say that an and bn one of them is a subsequence or not, because if if one of them is subsequence, then limit of both sequence will be same and will be unique, and then it will be a easy one problem. Sometimes examiner gave structure ways expression for problems or recurrence formula, because of whenever structure expression is given to us, sometimes students feel this problem is harder and they left the problem, but it is easiest one. So as a1 equal to 1, then an plus 1 can be obtained by an plus minus 1 raised to the power n, 2 raised to the power minus 1 minus n. Now a2 will be first term, and it means a1 plus minus 1 raised to the power. If n plus 1 here, then minus n n means less than 1 less, so it will be 1 here, and 2 raised to the power minus 1, it means 1 plus or minus 1, 1 upon 2, 1 minus 1 upon 2, it is a2. This is a2. Then a3 will be a2 plus minus 1 raised to the power n, means 2, and 2 raised to the power minus 2, it will be, here you can use a2 1 minus half plus this will be even power, so positive sign will be there, 1 upon 2 raised to the power 2, Now you can write this is 1 minus half plus 1 upon 2 square. It means if you find the nth term, then an will be 1 minus 2 plus 1 upon 2 square, negative means alternate positive negative, and last term will be minus 1 raised to the power n. If n is here, then minus 1, 2 raised to the power, or 1 upon 2, you can write n minus 1. N minus 1. Because n minus 1 is here, then by the reciprocal, 1 upon 2 raised to the power n minus 1, or you can write here as minus 1 raised to the power n minus 1, 2 raised to the power 1 minus n, like that. So it is looks better, so I wrote this form. Now an is written by this expression, and this is a geometric series with common ratio minus half, then its infinite sum can be obtained by a1 minus r by the formula this. So a is first term, it means 1 minus, it is by the formula, this minus is by the formula, and r is minus half here. So 1 plus half, it means 2 by 3. So limit of the sequence is 2 by 3, and it is convergent sequence we obtained here. An is convergent. Now think about Bn. First, Bn is defined as 2 times An plus 1 minus An by An. This is the formula based formation for Bn. So write Bn or express Bn with the help of or explicitly by the terms of An or An sequence An. So it will be 2 times An plus minus 1 raised to the power n, 2 raised to the power minus n, and minus An divided by An. It can be written down An, because of this is 2 times, and minus here minus An. So An plus minus 1 raised to the power n apply distributive property, 2 into 2 raised to the power minus n and divided by An. This is Bn in terms of An. This is Bn in terms of An, and we have to find the limit of Bn. Limit of Bn equal to, when n tends to infinity, An divided by An plus minus 1 raised to the power n, 2 into 2 raised to the power minus n divided by An. Now An cancelled here, so 1 plus minus 1 raised to the power n and 2 raised to the power n, 2 raised to the power n, or you can write 1 upon 2 raised to the power n, two by An here. Now this is 1 upon 2 less than 1, and 1 upon 2 raised to the power n tends to 0 when n tends to infinity. When n tends to infinity, because of this sequence is going to 0, so this term will be 0. 1 plus 0 equal to 1, and hence limit of bn equal to 1. As bn is convergent sequence and we are got a non-zero limit, so it is also convergent, and every convergent sequence is a Cauchy sequence. Now an is converges to a non-zero number. So conclusion is an is convergent and non-zero number converges to a non-zero number, and bn is Cauchy. So option B is true here.